Problem number 1. Problem number 1 starts off with the square root of 2x plus 2 minus 6 Problem number 1 starts off with the square root of 2x minus 2 minus 6 equals negative 2. Now, hopefully you remember from last year that in order to solve an equation, to identify the value of x, you need to work through your order of operations backwards. Now, the classes that I have had this year have learned that the order of operations backwards is SADMAP. And we write down SADMAP on our paper so that we can remember I need to undo any subtraction or addition first. We can utilize the inverse operation. I then can undo any division or multiplication using their inverse operations. I then can undo any exponents using its inverse operation. And finally, I can undo anything that's in parentheses. So, very first thing that sticks out to me is I have a minus 6. And in order to get rid of the minus 6, I can add 6 to it. What I do to one side of the equation, I have to do to the opposite side of the equation. So we end up with the square root of 2x minus 2 is equal to negative 2 plus 6, very important to be careful, is 4. Now, quite often here is where the next most common mistake is. Someone will look and say, oh, there's another minus 2. The inverse operation of subtracting 2 is to add 2. But it's very important to remember that that subtraction of 2 is actually sitting inside the radicand, which qualifies as an exponential power. Remember, anything that's written as a square root can also be written as a power of 1/2. So I could, in theory, write down 2x minus 2 inside parentheses, all raised to the 1/2 power. I'm not going to, because by now we've learned if there's something that has sitting inside the radicand that's a square root value, we can square the entire thing, and that would be the same as asking, what is the square root of 2x minus 2 times the square root of 2x minus 2? And we should remember back from Unit 5, that's simply 2x minus 2. Now again, our exponent laws dictate that what we do to one side of the equation, we have to do to the other side, so we're also going to square that value. And despite the fact that I don't need to put parentheses around the 4, it's a habit just to be in a good practice of making sure that I know that entire value on that side of the equation is getting squared. That will make more sense when you have a negative number over there, because there's some tricky rules that deal with negative signs in front of a number. Needless to say, 4 squared is 16. At which point, we have a basic two-step equation now. We're going to add 2 to both sides. 18 is equal to 2x, and we'll divide by 2. X is equal to 9. Now remember that you can check any answer anytime you're solving equations by simply taking that value of 9 and plugging it into your original equation. Problem number 2. 4 times the cube root of x plus 16 is equal to 32. So again, we want to work through our order of operations. Backwards, we're going to first subtract 16 from both sides. 32 minus 16 is in fact 16. So that leaves me with 4 times the cubed root of x. Now remember, I just said 4 times the cubed root of x. Since the cubed root of x is another exponential power, x raised to the 1/3 power, I can't do anything with that until I've undone all of the multiplication and division. Well, in order to undo the multiplication, I'm going to divide by 4. So the cubed root of x is equal to 4. In order to get rid of the cube root, I'm going to cube this. What I do to one side, I have to do to the other side. So the cubed root of x raised to the 3rd power leaves me with x. 4 raised to the 3rd power gives me 64. We're done with 2 problems. Number 3. Negative 2 times the square root of 5x plus 10 is equal to negative 20. Again, I need to look through my order of operations backwards. First thing I realize is that negative 2 is getting multiplied by everything in the radicand, so I can divide by negative 2. Negative 2 divided by negative 2 is 1, so that will simplify out. Negative 20 divided by negative 2 gives us positive 10. Now I want to get rid of that square root, so I'm going to square everything. What I do to one side, I do to the opposite side. And again, what's inside the square root will come out of the square root when I square it. And we see we're down to a 2-step equation again. So we'll subtract 10 from both sides. 90 is then equal to 5x. We'll divide by 5. And our value of x will then be equal to 18. Number 4. Number 4, we have the cubed root of 3x plus 9 is equal to 3. And so we're going to subtract 9 from both sides. Remember, we have a positive. We are taking or adding to it a negative value. 3 minus 9 becomes negative 6. Now I have a cubed root value inside the radicand, so in order to get rid of the radicand, we're going to cube this entire statement. And here we finally see a negative value on the right side of our equation, so you'll see that I will put it in parentheses so that I am cubing the entire value. If I take the if I cube a cube root, those 2 inverse operations simplify out, and that leaves me with 3x equals negative 6 times negative 6 times negative 6 gives me a negative 216, where we will divide by 3 on both sides of the equation, and x is equal to negative 72. Number 5, 3x squared minus 32 equals 43. Where we will first add 32 to both sides. Next, I notice 3 is getting multiplied to x squared, so I'm going to do its inverse operation and divide by 3. 3 over 3 is 1. That simplifies out and leaves me with x squared. 75 divided by 3 is 25. Where we still want our x value all by itself, so I will take the square root of x squared. And remember, that means I'm now looking for what pair is inside the radicand. The pair inside the radicand is x times x, so it will drop out an x. Equals, and what I do to one side, I have to do the other side. Square root of 25 is 5. And remember, both our positive and our negative values are solutions. Problem number 6. X squared plus 10 equals 14. This one should really be a very quick problem. We subtract 10 from both sides. 4 is equal to x squared, where we will take the square root of both sides now. The square root of x squared is x. The square root of 4 is 2, and we can use both our positive and negative roots. Now we want to remember why we can use positive and negative roots. If I first start with x can be positive 2, I can plug that into my original equation. 2 squared is 4, plus 10 is 14. Alternatively, we could also use negative 2. Negative 2 times negative 2 is also 4, plus 10 is 14. So both solutions work for this given problem. Number 7, x cubed plus 5 is equal to 517. First thing we're going to do is subtract 5 from both sides, where x cubed will equal 512. And we will take the cubed root now, since we have a x cubed, of x cubed, and that will drop out x. Again, if we're looking for a cubed root, that means we're looking for what set of 3 identical values are being multiplied together inside the radicand. X cubed is the same as stating x times x times x, so our identical value is x. We also want to take the cubed root of 512. The cubed root of 512 is 8. Now, when we're dealing with cubed roots, it's no longer positive and negative 8, because when I multiply a positive times a positive, it stays positive. When I multiply that by another positive, it stays positive. When multiplying negative values, remember that if I multiplied negative 8 times negative 8, that would become positive. And then 64 times negative 8 would give me negative 512, which does not give us a solution to the original problem. So we're only looking for the positive root when we have a cubed root. Problem number 8, 2x cubed minus 4 equals 12. Again, following my order of operations backwards, first thing I'm going to do is add 4 to both sides. So 16 is equal to 2x cubed. Now remember that 2 is getting multiplied to x cubed, so I want to do its inverse operation, divide by 2. 2 over 2 is 1, so that will simplify out. 16 divided by 2 is 8. So again, we want to take the cubed root. The cubed root of x cubed is simply going to be x. The cubed root of 8, what number multiplied 3 times gives us 8? That is 2. Problem number 9. Find the length of the diagonal of a rectangle whose length is 6 inches and whose width is 8 inches. I'm a big proponent of drawing images, so the first thing I'm going to do is draw an image. It has a length of 6 inches, that's going to be my shorter side, and a width of 8 inches, that's going to be my longer side. And the problem asks us, what is the diagonal? Now we should remember that since this is a rectangle, each of my corners is 90 degrees. And since each of my corners is 90 degrees, that means when I draw the diagonal in, we have created a right triangle. And for any right triangle, we can find the side length of the hypotenuse by using the Pythagorean theorem. The Pythagorean theorem states that a squared plus b squared is equal to c squared. So we discussed in class that the value of a squared and b squared, the value of a and b are interchangeable as long as you use one of the legs for each value. So a squared, we'll go ahead and use 8 squared plus my b, we'll use 6 squared equals c squared because we still don't know the lengths of the hypotenuse. 8 squared is 64. 6 squared is 36 equals c squared. Now 64 plus 36, that gives me 100 equals c squared. And since we have a squared value, we take the square root of it, and we end up with 10 is equal to c. And I know we just went through several problems where we took the square root on both sides and we ended up with a positive and negative value. And that would certainly be true had this not been that we were looking for a distance of a line. And you should also remember that distance is always positive. So we don't need to worry about the negative root, even though it would be a justifiable solution to the equation we set up. It's not a justifiable solution to a distance. Problem number 10. The top of a 20-foot ladder reaches a window ledge. The ledge is 16 feet above the ground. So my image might look something like this. I have a building with a window ledge and a 20-foot ladder that's leaning up against it. How far is the house from the foot of the ladder? So if I notice from the house to the foot of the ladder, that completes a right triangle. So we end up with 16 feet up, a 20-foot ladder, and an unknown value right down here. Since we have a right triangle and we already know the longest length of that triangle, that means we know the hypotenuse, we know the c value. So we're still going to use the same equation, a squared plus b squared equals c squared. And if you haven't gotten the gist from class, I'm a big proponent of making sure that you write down the formula for any question. I know that by now you've probably gotten used to using the formula. I have too, and if I can write it down, you can continue to write it down also. So a squared. Now, I also told you in class that my b's often look like 6's. So if I can, I'm going to keep my a squared as a variable because I like to replace the b with whatever number I can. So we're going to go ahead and say a squared plus my value of b squared, so 16 squared, is equal to 20 squared. Where we will end up with a squared plus 256 is equal to 400. We subtract 256 from both sides. And a squared is then equal to 144, where we should recognize pretty quickly that 144 is a perfect square. So we're going to take the square root of both sides, and A will be equal to 12 feet. Problem number 11. A wire stretches from the top of a pole, which is 15 feet high, to a stake on the ground, which is 8 feet from the foot of the pole. Find the length of the wire. Now we're told that the pole is 15 feet high. And the stake, which is sitting over here, is 8 feet from the pole. So again, we're looking for the hypotenuse. A squared plus B squared equals C squared, where my value of A will be 8 squared plus B will be 15 squared is equal to C squared. 8 squared is 64 plus 225 is equal to C squared. 64 plus 25 is 289 is equal to C squared. So we take the square root of both sides, and the square root of 289 gives me 17 is equal to C. The length of the wire is equal to 17 feet. Problem number 12. Find the missing side lengths for each triangle. Now, we can notice right away that these are right triangles, but we're only given one value. Now, we could certainly use Pythagorean theorem and substitute a variable for both of our side lengths. And actually, I'm going to go ahead and show you how that works. So, problem number 12. If I have my isosceles triangle and a hypotenuse that is equal to 28, then I know right away that that side and that side are both equal to each other. So I could very easily say, using my Pythagorean theorem, a squared plus b squared is equal to c squared. So my a squared, for this problem, we're going to substitute in the value of the variable, x squared, and again, the value of my other side length, x squared, is equal to c squared. Now we'll simplify or condense. X squared plus x squared is 2x squared equals 784. Where we will divide both sides by 2, and x squared is equal to 392. And we will then take the square root of both sides, and x is equal to the square root of 392. My factors of 392, let's see, I can divide by 2, so square root of 2 and square root of 196. And so x will be equal to 14 root 2. Now that was certainly one option. Option B, I'm going to go ahead and show you for this problem. Just another way of solving it. Remember that with any 45, 90 triangle, our solutions are going to be x, x, and x root 2. Now, x root 2 is the length of the hypotenuse, but we're told that the hypotenuse is 28. So 28 is equal to x root 2. Now we just simply have to solve the equation, find the value of x. That will tell us the side length. So I'm going to divide both sides by 2. Root 2 over root 2 is 1, so that will simplify out. And I'm going to go ahead and move my x to the right side, or left side, equals 28 over root 2. Now we talked about in class that you cannot have a radical in the denominator. In order to get rid of the radical in the denominator, we multiply by a fraction that has that same value in the denominator. So that when I multiply root 2 times root 2, I clear out the radical. This is similar to our concept of clearing fractions that we looked at earlier this year. Now, in order to make sure that I remain with an equivalent fraction, whatever I put in my denominator, I'm going to also put my numerator. So I'm multiplying by root 2 over root 2, which is the same thing as multiplying by 1. It's just working in a way that will clear out our radical from the denominator. Root 2 times root 2 is equivalent to 2. 28 times root 2 is the same as 28 root 2. Where we should see real quickly, 28 is divisible by 2, so that must be x is equal to 14 root 2. Where either way we solve this problem, we end up with the exact same solution. Problem number 13. Problem number 13 requires that you then that we actually use our special triangle rules. For this particular triangle, we end up with x root 3, 2x, where x is my side length across from the 30-degree angle, x root 3 is my side length across from my 60-degree angle, and 2x is my side length across from my 90-degree angle. Since we're dealing with a side length across from my 90-degree angle, we're going to deal with the 2x expression. And we're given a length of that side length. The hypotenuse is 60. Well, since it's true that the hypotenuse is 60, and it's also true that the hypotenuse on a 30, 60, 90 triangle is also 2x, we can set those two statements equal to each other and solve for x. So I'm going to divide both sides by 2, and x is equal to 30. So now my shortest side length on the triangle is equal to 30. My hypotenuse is equal to 60. But we still need to figure out the value of my third side. We stated earlier that the side length across from the 60-degree angle is x root 3, and we now know the value of x to be 30. So my second side, we will substitute in the value of x, 30 root 3. Problem number 14, find the altitude for each of the following triangles. While looking at this triangle, I can see that it has a 60-degree angle and it has a right angle, which means the other angle that's not labeled is 30 degrees. So we're dealing with a 30, 60, 90 special right triangle. We're also given the hypotenuse. And the hypotenuse is 2 times my shortest leg. So let me start off with a little bit of an image that looks similar to what we got here. My hypotenuse is 80, and that's 2 times my longest leg. So without doing any math, we should be able to say, oh, the longest or the shortest leg is half of that. That would be 40. The longer leg, or the altitude of this triangle, that's on a 30, 60, 90 is equivalent to x root 3, where we just stated that the x leg is 40, so we will substitute in what we know. So instead of x, we will end up with 40 root 3 as the altitude for the triangle. Number 15, similar process is taking place. We have a 30, 60, 90 triangle again. The base appears to be 80 and appears to be bisected. Probably would be more practical for me to give you indicators to tell you that both of those segments on the base of the larger triangle are equivalent. I'm going to go ahead and tell you that they are, and hopefully we'll correct this for future years. So that would mean then we should have a triangle that looks something like this. Now, if the base of this bigger triangle is 80, and I'm telling you that both of those halves on the bottom are equivalent or congruent, then each section is 40, which means, again, in a 30, 60, 90 triangle, we have x root 3, 2x. The base value, or the value of my smaller leg, is 40. We're looking for the altitude, which is going to be my longer leg, which uses the expression x root 3. And we just stated the value of x was 40, so our solution is going to be 40 root 3. The volume of a cylinder is 128 cubic inches. If the height of the cylinder is 2 inches, what is its diameter? Now, in order to calculate its diameter, since we're given the volume, we're going to be working backwards. And we first want to start with our formula. Volume is equal to, since this is a cylinder, big B times H. Now we're going to fill in what we know. We're told that the height of the cylinder is 2 inches, and we're told that the volume is 128 pi cubic inches. So volume, instead of writing V again, I'm going to write 128 pi is equal to big B times 2, because that's the given height. Where now I can isolate a variable at least, divide by 2. And 128 divided by 2 gives me 64 is equal to my base. Now we got to ask the question, what shape is the base of a cylinder? The base of a cylinder is a circle. And a circle uses the formula pi r squared. So now we are looking for the value of our r, because if we know the value of the radius, we can identify its diameter. Since I have pi on both sides of the equal sign, and my pi functions like a variable, I can divide both sides of my equation by pi, and they will simplify out. And so that leaves me with 64 equals r squared. By now we're getting good at our square roots, so we know that r is equal to 8. And if my r is equal to 8, and that's half the distance of across the circle, then my diameter, which is the full distance across the circle going through the center, is equal to 16. And that's working backwards using a known volume formula. Problem number 17. What is the volume of a cylinder that has a diameter of 16 centimeters and a height of 6 centimeters? So again, we're going to be using our formula. Volume is equal to big B times H, where we first need to find the value of the big B. So I'm going to start with my big B, and its shape is a circle, which uses the formula pi r squared. And in the problem, we're told that the diameter is 16, and since the diameter is the entire length of the line that goes across the circle through its center, we need to know the value of the radius, which is half of that diameter. Half of 16 is 8. So B is equal to pi times 8 squared. 8 squared is equal to 64, so B is equal to 64 pi. And now you'll remember from class that I've encouraged you to utilize your exact solution until you've completed the problem and you're ready to approximate. That way you don't end up with additional compounded approximation error. So now that we know the value of B, we're going to take it and plug it back into our original equation. Volume is equal to big B, which we now know to be 64 pi, times the height. And we're told that the height is 6. And now we can multiply these values together, where my volume is equal to 384 pi centimeters cubed. Now that's going to be my exact solution because it has pi present in the solution. But the question didn't ask for an exact or an approximate, and since it didn't ask, we're going to be more accurate and go ahead and give both answers. I know it's one more step, but you can handle it. And so in order to give one more further step, we take our 384 and we use an approximate value of pi. And the approximate value of pi that's most typical is 3.14. So 384 times 3.14 gives us a volume that is approximately, notice the approximate symbol, 1205.76 centimeters cubed. And so that whole thing will be our solution. Problem number 18. What is the volume of a cone that has a radius of 6 centimeters and a height of 8 centimeters? Well, this is going to use a slightly different formula, where the volume of a cone is equal to 1/3 of our big B times H. And so, again, we need to know what is our base. Well, the base of a cone is round, so that's going to be a circle, and it will use the formula pi r squared. And so again, we're going to find the radius is told to be 6. So base is equal to pi times 6 squared, where 6 squared is 36. Base is equal to 36 pi. And now that we know the value of the base, we can take that and plug it back into our original formula. Volume is equal to 1/3 times the base, which is 36 pi, times the height, which is 8. And we can clean this up a little bit. 1/3 times 36, so that would be 12, times 8 is 96, so volume is equal to 96 pi centimeters cubed. Again, that's our exact solution. In order to get our approximate, we multiply 96 times 3.14 And our volume is approximately 301.44 centimeters cubed. And so both of those would be justifiable answers for this particular problem. Problem number 19. Find the radius of a sphere that has a volume of 36 pi centimeters cubed. Well, this is going to require us to know the volume of a sphere formula, where volume of a sphere is equal to 4/3 pi r cubed. Now, when you're dealing with spheres, this is where learning those cubed roots is going to become very valuable, especially when you're dealing with typical textbook or classwork style problems, because our goal is to ensure that you know how to find the area of a sphere, not necessarily to give you problems that are dealing with crazy numbers all the time. So you will find that quite often it is the case. Textbook problems and classwork problems tend to focus on using cubes that are perfect cubes, and they tend to use problems that are 1 through 10 perfect cubes, which is ironically the ones that you're working on memorizing. So, we're looking for the radius, which means we know the volume. We know the value of V, which is volume, is to be 36 pi. And in order to identify the radius, we're simply going to utilize our formula as our given expression to help us solve for our radius. Now, first thing I should notice right off the bat is I have pi on both sides of the equation. So if I divide both sides by pi, pi over pi is going to simplify out to 1, and those will both simplify out. Now, as you get more practice with solving equations, you're going to realize that anytime you have the same thing of something on both sides of the equation, they're going to clear out each other. But you can still show your step as I did. 36 is equal to 4/3 r cubed now. Where I have 4/3 multiplied to r cubed, I have got to deal with the fraction first. In order to clear a fraction, we multiply by its reciprocal, so 3/4. Where I notice, hey, the 3 and the 3 clear each other out, the 4 and the 4 clear each other out. What I do to one side of the equation, I've got to do the other side, so I'm going to multiply this side of the equation by 3/4. Where 36 divided by 4 gives me 9. 9 times 3 gives me 27. So we end up with 27 is equal to r cubed. In order to get r by itself, we take the cubed root of r cubed and the cubed root of 27, and we identify r to equal the value 3. Problem number 20. A sphere has a volume of 480 pi centimeters cubed. The radius is increased using a scale factor of 3. What is the new volume? Now, our focus for this unit is for us to be able to use a given volume, identify its radius, apply a scale factor, and then find a new volume. There are certainly shortcuts that you will learn in higher levels of math, and that I have taught in this level of math. But I still need for you to be able to show me the expectation for this standard, which is that you can work backwards to find the radius. So that's what I'm going to show you. 480 pi is equivalent to, since we're talking about volume of a sphere, the formula for volume of a sphere. 4/3 pi r cubed. Where again we have pi on both sides, so I can divide by pi on both sides. And they will simplify out, and we're left with 480 being equal to 4/3 r cubed. where we can multiply by the reciprocal. So multiply by 3/4. And the 4/3 and 3/4 will simplify each other out, leaving me with r cubed. The 3/4 times 480 will leave me with 360. It's where we take the cubed root of both sides, and r is now equal to the cubed root of 360. Now, 360 does not cube down into a simple, clean, easy value, which is okay because I don't really need it to. We just need to know what the radius is, and if we have an r value set equal to another value, we know its radius. We also know that we're increasing this shape by a scale factor of 3, which means I'm multiplying this given radius times 3. Well, that would make my new radius 3 times the cubed root of 360 where we plug all of that into our volume of a sphere formula. And we're going to notice real quick that when I plug in that volume, that cubed root, cubing it is going to pull it out of the cubed root, and so we'll see how that works in just a minute. Volume is equal to 4/3 pi times 3 times the cubed root of 360 cubed. Now we should remember back from Unit 5 that if I have a times b raised to the third power, that's the same as saying a to the first power times b to the first power raised to the third power. And our power of powers rule will end up multiplying those two powers together, and we're left with a to the third power times b to the third power. And so that's what's going to happen here with this term inside the parentheses. So let me clean up this step. V is equal to 4/3 pi times 3 to the third power, which is 27, times 3 to the cubed root of 360 to the third power, and that's simply 360. And so we should be able to clean this up a little bit. 4 times 27 times 360 divided by 3, where our new volume is equal to 12,960 pi. And we started off in centimeters, so we will end in centimeters cubed. Problem number 21. A sphere has a volume of 32 over 3 pi inches cubed. The length of the radius is reduced by a scale factor of 1/2. Well, again, we need to work back to our radius, so is equal to, 4/3 pi r cubed. So again, we will divide by pi on both sides. 32 over 3 is equal to 4/3 r cubed, and we will multiply by the reciprocal of that fraction to clear it out to both sides of the equation. To where now the cubed root of r cubed is equal to r. The cubed root of 8 is equal to 2. So our radius for the original problem was equal to 2. It's getting reduced by a scale factor of 1/2, so I'm going to multiply 2 times 1/2, which is going to equal 1. That's going to make solving our volume very easy. Volume is equal to 4/3 pi r cubed, where if my r value is 1, 1 cubed is 1. 1 times anything is whatever was there, so our volume is going to be equal to 4/3 pi. So our volume is approximately 4.9 inches cubed. Problem number 22. What effect does scale factor have on the volume of a three-dimensional figure? Well, I'm not going to go ahead and give that to you. I'm going to let you look back at your previous problems and look back at your homework from Tuesday and kind of figure it out. So that skips us then to problem 23. Determine if the triangle with a given side length is a right triangle. Now I'm going to do a couple of these, but not all of them, because once you figure out the pattern, you should be good to go. The pattern is, if it makes a right triangle, then the Pythagorean theorem will work and justify its solution. Let's see how. A squared plus b squared is equal to c squared, where a and b simply have to be the smaller of my two numbers because c is always the hypotenuse which is longest. So looking at my first problem, for 9, 40, and 41, 9 and 40 are my smallest two numbers, so 9 squared plus 40 squared is equal to 41 squared. So we end up with 9 squared, which is equal to 81. We end up with 40 squared, which is equal to 1600. And we end up with 41 squared, which is 1681, where we can add the expression on the left, 881 plus 1600. 1681 is in fact equal to 1681. So at this point, we would say yes, it is a right triangle, proven by the Pythagorean theorem. B gives us 15, 111, and 114, so my a squared plus b squared equals c squared. My a value will be 15, plus my b value will be 111, equals my c squared, which is 114. My a squared is 225. My 111 squared is 12,321. My 114 squared is 12,996. So we end up with 12,546 is equal to 12,996, at which point we say, no, it's not. And our solution to B is no. Now, From these two, we should be able to follow the pattern and solve the remainder of the problems. (24) What is the distance between the points 3, 2 and 7, -1? So we are going to be using the distance formula because we have two ordered pairs. Remember, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Rewrite that addition sign because I think I just went through it with my parentheses. Now, we should remember the distance formula is an application of the Pythagorean theorem. This is basically my x2 minus x1 squared is my a squared. My y2 minus y1 squared is my b squared. And since they're taking the whole square root of that, that means we originally had d squared, which would typically be our c squared. So yes, I realize a bunch of letters, a bunch of numbers, but the big thing for us to remember is it is an application of Pythagorean theorem, to where we now just need to know which one of these is my first ordered pair. So I'm going to label that as my first ordered pair, that is my second ordered pair, so I know which x's and y's I'm pulling from. And d is equal to the square root of my x2, which is 7, minus my x1, which is 3, squared, plus my y2, which we said was -1, minus my y1, which is 2, squared. And now we just clean it up. This is using basic algebra rules. D is equal to the square root of 7 minus 3 would be 4 squared, plus -1 minus 2 is -3 squared, where d is equal to now the square root of 16 plus 9. D is equal to now the square root of 25. And d is equal to 5. So the distance between those two ordered pairs is 5. Number 25. What is the distance between the points 5, 2 and -2, 4? Again, d is equal to the square root of and again, you're noticing that I'm writing out the formula. No, it's not because I need to know what the formula is. It's because it's a good practice to write out the formula before any problem. It helps to reduce the quantity of mistakes, and it helps to reassure that that's going to stick in your mind from now until you're done with your high school math. So d is equal to, I'm going to label my ordered pairs, first ordered pair, second ordered pair. So my x2 would be -2 minus my x1 would be 5 squared, plus my y2 would be 4 minus y1 would be 2 squared. D is equal to the square root of -2 minus 5 is -7 squared. 4 minus 2 is 2 squared. D is equal to the square root of 49 plus 4. So D is equal to the square root of 53. And since the 53 only has factors of 53 and 1, that's as simplified as it can get. We could certainly approximate our solution. Our approximate solution would be D is approximately 7.28 units long. (26) What is the distance between points -5, -1, and -2, 4? Not sure why I have 2 question marks on this problem. Again, I'm going to have ordered pair 1 and ordered pair 2, where D is equal to square root of x2 minus x1 squared plus y2 minus y1 squared, where we plug in our values. D is equal to the square root -2 minus -5 plus 4 minus -1 minus a negative. Remember, that's the same as adding, so D is equal to the square root of -2 plus 5, which is going to give us 3. 4 plus 1 is 5. D is equal to 3 squared is 9, plus 5 squared is 25. So D is equal to the square root of 34. Where that's factors are 2 and 17. So it's not going to simplify any further. It will have an approximate value of 5.83 units. What is the area